Hi friends, welcome back to my channel. So in today's class, we're going to talk about compound inequalities. So what is a compound inequality? A compound inequality is two inequalities joined together by the words and, or we use the word or. Now, for an inequality with the word and, both conditions of such inequality must be the same. Both conditions must be the same. That is, if we are given x to be greater than 2 and x to be less than or equals to 7. This particular inequality can be re-expressed by combining these two inequalities. That is, we can re-express this and say x is greater than 2 and x is less than or equals to 7. Now, from this expression, we can list out the possible integers. Since x is greater than 2, and x is less than or equals to 7. So the number range is between 3 and 7. So let's list out the possible value. 3, 4, 5, 6, and 7. Now, we can as well represent this expression on number line. That is, if we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On number line, the possible value can be determined on number line. X is greater than 2. X is greater than 2. And x is less than or equals to 7. So we are going to shade this because x is less than or equals to. Now, if we combine this line, the possible integers is going to be between this value 2 and 7. So using the number line, we can as well determine the possible integers of the inequalities involving the word and. So let's consider the second inequality involving the word or. So for an inequality involving the word or, only one condition can be true. Only one condition or probably both conditions can be true. Now let's consider this inequality: x less than minus 3 or x to be greater than 5. Only one of these inequality will be true. That is, if x is less than minus 3, the possible integers of this x is going to be minus 4, since x is less than minus 3, minus 5, minus 6, minus 7, and many more. Or the possible value of the second inequality is going to be x is greater than 5. So we start our number from 6, 7, 8, 9, and many more. Now, before we proceed, let's also consider the rules we need to adopt when solving a compound inequality. What are the rules we need to put into consideration when we're solving compound inequalities? To solve compound inequalities, the first rule we need to put into consideration is that we treat the compound inequality separately. We have to treat the compound inequality separately unless it is written as a single three-part inequality. So the second rule we need to put into consideration when solving a compound inequality is that we perform same mathematical operation on both sides. That is, if you subtract from left hand side, you must subtract from the right hand side. And as well, if you had a value at the right hand side, you have to add a value at the left hand side. So the third rule says that whenever we multiply or divide a value when solving a compound inequality by a negative number, we have to reverse the inequality sign. And finally, we have to interpret the connector, or we find the possible value of the answer we got. Now, let's consider the following question one after the other. So to solve the first compound inequality question given to us here, can use several methods to solve this, but I'm going to show you two different methods here. So the first method is to expand the inequality given to us by saying 2 less than or equals to 3 plus x, and we say 3 plus x less than 5. The next thing is to collect the like terms, or you subtract 3 from both sides. Subtract 3 from both sides. So we're going to be having 2 minus 3 less than or equals to 3 minus 3 plus x. And for the other side, we subtract 3 from both sides. So we're going to be having 3 minus 3 plus x less than 5 minus 3. So we proceed. This will be 0 plus x less than 2. So x will be less than 2. The second one will be minus 1 less than or equals to 0 plus x. Therefore, our final answer is going to be minus 1 less than or equals to x. So the next thing we need to do now is to combine this inequality solution. So we have minus 1 less than or equals to x and x less than 2. Therefore, we're going to be having x to be greater than or equals to minus 1 and x to be less than 2. Now let's consider the second method. You can now choose the one that you prefer from these two methods. So for the second method, all we need to do here, if you are given the compound inequality, all we need to do here is to subtract 3 from both sides. We have 2 minus 3 less than or equals to 3 minus 3 plus x less than 5 minus 3. This will be minus 1 less than or equals to x less than 2, which is still the same thing as the answer we have here. Now, since x is greater than or equals to minus 1, the possible integer is going to be minus 1, comma 0, and x is less than 2. X is less than 2. So our possible integer will be minus 1, 0, and 1. That will be the possible integer. So let's consider the second question. The second question says we should solve 6 minus 3x less than or equals to 7 minus x less than or equals to 10 minus 2x. So in this case, we can expand this compound inequality and solve them separately. So we say 6 minus 3x less than or equals to 7 minus x. And the second expression is going to be minus 7x less than or equals to 10 minus 2x. So if we collect the like terms, we're going to be having minus 3x plus x less than or equals to 7 minus 6. And for this other one, we're going to be having minus x plus 2x less than or equals to 10 minus 7. So recall that any operation that crosses the border of inequality sign is going to change operation. Minus is going to change to plus, and plus is going to change to minus. That's what exactly we did here. So if plus 7 crosses the border of this inequality, is going to change to minus 7, and minus 2x that crosses the border is changing to plus 2x. So let's solve this completely now. We're going to be having, this will be minus 2x less than or equals to 1. The other one is going to be x less than or equals to 3. If we divide both sides by negative 2, the operation is going to change. So my x now is going to be greater than or equals to minus 1 over 2. And the second solution is going to be x less than or equals to 3. So if we combine this solution, our x is going to be greater than or equals to minus 1 over 2, and x will be less than or equals to 3. So let's consider the possible integers of this solution. possible integers will be x is less than or equals to minus 1 over. So the possible solution will be minus 0.5, comma 0, comma 1. Then x is less than or equals to 3. Then we have 2 and 3. So these are the possible integers of the solution x greater than or equals to minus 1 over 2 and x less than or equals to 3. So let's consider the third question. So the third question says we should solve this compound inequality involving the word or. So we have x minus 4 less than minus 1 or x plus 2 greater than 8. For the first inequality given, to find the value of x, we have to add 4 to both sides. And for the second inequality, we have to subtract 2 from both sides. So let's move on. We have x minus 4 plus 4 less than minus 1 plus 4 or x plus 2 minus 2 greater than 8 minus 2. So here we're going to be having x to be less than 3 or x to be greater than 6. So to consider the possible integers of these two solutions, of which only one of these inequality will be true. So if x is less than 3, the possible solution, possible integers is going to be 2, 1, 0, minus 1, minus 2 to infinity. And the second solution, x is greater than 6, we'll be having 7, 8, 9, 10 to infinity. So these are the possible integers of the two solutions. Let's consider the fourth question. Right, so the fourth question says we should solve 5 less than or equals to 2x plus 1 less than 11. So this way, we can subtract 1 from both sides so as to find the value of x. So we have 5 minus 1 less than or equals to 2x plus 1 minus 1 less than 11 minus 1. So this will be 4 less than or equals to 2x less than 10. Alright, so we divide both sides by the coefficient of x here, which is 2. We divide both sides by 2. So we have 2. This will be 2 less than or equals to x less than 5. So our answer is x is greater than or equals to 2 and less than 5. So the possible integers of this solution include, since x is less than or equals to 2, so we're going to start our number from 2, and x is less than 5. So we have 2, 3, 4. So this will be the possible integers of this solution up here for the fourth question. So let's move to the next question. So the next question is 3 less than x plus 2 less than or equals to 9. To solve this, we have to subtract 2 from both sides. So we have 3 minus 2 less than x plus 2 minus 2 less than or equals to 9 minus 2. This will be 1 less than x less than or equals to 7. So the possible value here, since x is greater than 1, possible integers, x is greater than 1, so our number is going to start from 2, 3, 4, and x is less than or equals to 7. Our number is going to stop at 7, so we have 5, 6, and 7. So these are the possible integers. Now, the next question, which is the sixth question, says we should solve 8 less than 2 over 3x plus 6 less than or equals to 12. Alright, to solve this, the first thing we need to do is to subtract 6 from both sides. That is 8 minus 6 less than 2 over 3x plus 6 minus 6 less than or equals to 12 minus 6. We're going to be having 2 less than 2 over 3x plus 0 less than or equals to 6. So the next thing we need to do is to multiply both sides by 3 so as to eliminate this denominator here. So we have 2 times 3 less than 2 over 3x times 3 less than or equals to 6 times 3. 3 will cancel out 3 here. So we have 6 less than 2x less than or equals to 6 times 3. That's going to give us 18. The next thing we need to do is to divide both sides by 2, the coefficient of x. Divide both sides by 2. This will be 3 less than x less than or equals to 9. So our final answer now is x is greater than 3 and x is less than or equals to 9. So the possible integers will be 4 since x is greater than 3, 4, 5, 6, 7 and less than or equals to 9, 8 and 9. This will be our possible value for the question 6. So let's consider the final question. Say we should solve 3x plus 5 less than 8 or minus 2x plus 5 less than or equals to minus 1. So we solve separately and we find the possible value of each inequality given here. So we have 3x plus 5 minus 5 less than 8 minus 5 or minus 2x plus 5 minus 5 less than or equals to minus 1 minus 5. So this will be 3x less than 3 or minus 2x less than or equals to minus 6. So divide both sides by 3. X will be less than 1 or divide both sides by minus 2. Don't forget, if you divide any number by minus 2, your inequality sign will change. So x now will be greater than or equals to 3. Therefore, the possible value of x here is going to be, since x is less than 1, the possible value is going to be 0, minus 1, minus 2, minus 3 to infinity. Or x is greater than or equals to 3. X is greater than or equals to 3. So we're going to be having 0, 1, 2, and 3. This will be the possible value. And we can as well combine our solution. And we say to infinity minus 3, minus 2, minus 1, 0, 1, 2, and 3. So this will be the possible value of the solution here. So if you like my video, kindly subscribe to my YouTube channel and click the notification button so as to receive every new video I'm going to be dropping on this channel. So in the next class, we're going to discuss representation of inequality on number line. But before then, I'm going to post some questions for you to practice to test your knowledge on how to solve compound inequality. See you in the next class. Bye.